thanks for coming along, Bruce, to chat to us today. This is a part of the AgriFutures Future Fibre Farming Goat program, trying to encourage more people into the industry. And by doing so, we've started up the Goat Fibre Gateway and building and finding more resources to put on it every day. So that's where this recording will be posted once it's finished, and we look forward to hearing from you. We'll take some points of clarification during, if anybody has some, and afterwards we'll have some time for questions. Over to you, Bruce. Thank you.
No problems. Thanks, George. Yeah, well, we've got a PowerPoint presentation we've got to load up, so we better do that, I suppose. Okay, you ready to go? So what the subject tonight is talking about the impact of nutrition on mohair follicle development and the impact on fibre diameter and fleece weight. This is a really interesting issue. There's quite a few aspects of goat farming that impact on lifetime fibre production and fibre quality and fibre value. So I've listed six of them here. Nutrition management, and we're going to talk about this tonight, nutrition management and skin follicle development. A lot of farmers are also interested in what's called micron blowout, which is fibre diameter increasing with the age of an animal. There's also genetic improvement. There's a way in which you evaluate fleeces. Fleece evaluation is important because it can influence how you progress in your genetic improvement and so on. There's a number of other issues that impact on fleece value, and shearing management is also really important. So look, what we're going to do tonight is just talk about the first one, nutrition management and skin development. So I just want to briefly cover what's known. So there's been quite a bit of science looking at follicle development in merino sheep in particular, and also in Angora goats. So this is a sort of a broad summary of what's known. And I've got a table up here, or it's a chart really, showing pregnancy, the period of pregnancy, and also lactation. So pregnancy goes for about 21, 22 weeks from conception to kidding, and then obviously you've got lactation running out. So what I'm going to do is just to put up a number of important issues, some sort of key events that we know happen. Now, these aren't exactly precise because this is difficult science to do, but this is the sort of broad times for development. So this is about the development of the young animal. So we've got conception here. Several weeks into pregnancy, the placenta starts to develop, and it's the connection between the mother and the fetus, and it develops early in pregnancy and continues on to about week 13 or something like that. After about 65 days, the primary follicles in the skin start to develop. So they're calling them primary follicles because they're the first ones that develop, and they continue to develop for until about day 120, roughly, approximately day 120 of pregnancy. And at the end of that period, there's some secondary follicles develop as well. They're called secondary because they come after the primary ones, and we'll talk more about that a little later. And from about day 100, roughly, the last 8 weeks or so of pregnancy, the fetus puts on about 85% of its growth. So a huge amount of growth in those last 50 days or so of pregnancy. And that coincides with the mammary glands developing as well. So they can grow in that period of time. There's also a key little time period here about day 100 where goats have a different hormonal arrangement compared with sheep. And if you put too much pressure on, too much nutritional stress on, then goats can abort. So they seem to have adapted to abort, which avoids this big growth period. It's quite an interesting evolutionary adaptation. You get to kidding time. The mammary glands keep developing. It takes about 2 weeks for lactation to really kick in, and you'll have the lactation obviously during that following period, provided there's a kid at foot, and secondary follicles do a lot of development during that time. So what I want to talk to you about is an experiment that I did some years back, which looked at this series of events to see if we could influence the number of secondary follicles in particular and influence the quality of the mohair fleece. So this is just a broad diagram here showing the sort of relative size of some of these fibres during the development, and it's showing here primary follicles here, fairly big and coarse. So on Angora goats and cashmere goats, it's really obvious with the birth coat, that'd be quite hairy. Most sheep also have a lot of primary follicles, can be quite hairy birth coats, and the secondary follicles are usually quite small, and not many of them. So this is just a rough diagram to give you an idea, whereas when you've got a mature fleece, there's a lot more secondary follicles, and the primary follicles are usually relatively smaller in size, or there's competition. There's sort of theories about competition here, and you can imagine how that works, where initially there's not many secondaries, but later on there's a lot more. So, as I said, what I'm going to do is talk about an intensive experiment. I'm just going to briefly explain it. I'm going to talk about the key results, only a few results. We'll be talking about skin follicles and fibre diameter, and I've got an estimate of the fleece value as well. So in other words, what's the impact of the different treatments we applied to these issues that we want to focus on. And just to get your attention quickly, this photograph shows the extremes in the experiment. So the animals here on the left were in the worst combination of nutrition treatments, and the animals on the right were in the best combination of nutrition treatments. And I'll give you the production information for these animals later, but you can see here that this kid here is about twice the size of the one on the left. So the way this experiment was conducted was that we AI'd all the does. So conception was by artificial insemination, so we knew exactly when that occurred. We scanned all the does at day 43 after artificial insemination. It's about the earliest you can do to fairly reliably pick up pregnancy. So the staff we had were very experienced. They'd done many thousands of scans, so they're pretty reliable. And then 4 days later, we put them into a feedlot in individual pens. I'll show you a photo of that in a moment. So here's the feedlot setup. We had fairly large pens. You can see some of the animals sitting down and resting. There's shade provided with the shade cloth. Every pen had its own feed trough and its own water supply, and each pen had a gate so we could take animals in or out. And the bottom photograph shows some of the staff who worked with me on this feeding out. We made pelleted diets with lucerne and barley and trace minerals and so on. So it's a complete diet, and they were fed every day with amounts of feed that I determined very carefully. So we wanted these animals to grow in particular ways, and so 3 times a week I would be adjusting their feed based on where we wanted them to grow, or how we wanted them to grow, and also whether there'd been any leftovers. We didn't want to waste too much feed. If animals weren't eating their amount, then we fed them a bit less. We didn't want to waste feed. So the way in which this experiment was designed was that we had 3 nutrition treatments during mid-pregnancy, and I'll show you this in a graph in a moment so you can get a much clearer idea of this. So it's basically from when they entered the feedlot, which is just before day 50, until about day 100. That's the middle third of pregnancy. And we then had 2 nutrition treatments after kidding. So before the experiment started and in the middle section, the animals were given similar nutritional management. And so we end up with six combinations. So there's 3 in the mid-pregnancy, 2 afterwards, 3 twos are 6. And the way we organised that was to put groups of 6 animals that had similar pregnancy status. So were they singles or twins, and a similar live weight. So for example, we might have had 6 does that weighed 40 kilos and all had singles, and so they were randomly assigned to one of those 6 treatments. So at the start, 2 of them would have been in each of the 3 nutrition treatments in mid-pregnancy, and once kidding happened, the individual animals then went into their other treatments. So a key part of this work was to make sure that what I would regard as normal, or the control, was the key point for doing this experiment. And for this experiment, the control treatment was what we regarded as typical live weight change during winter in southern Victoria, which is where we did the work. So we knew from many other studies that goats typically lose weight during the cold winter when feed supply is short. So we used that as the control. So I just overlaid these things. This diagram looks a little messy, but I'll just talk you through it. So in the background, we have the earlier information about normal development. And so conception was by artificial insemination. About week 6, we put the goats we scanned them and put them into the feedlot, and we applied the nutrition treatment. So you can see that treatment's happening while the placenta is still developing and before the primary follicles are being initiated. So we were trying to influence primary follicle initiation. In other words, could we get more or less of them by treating them in different ways? And then about day 100, we changed the feed because the best practice guidelines is to feed animals very well in the last 6 weeks of pregnancy, because that's when the fetus grows. There's no point starving them then. If they abort, there's no kids, and you don't have to worry about follicles. It just doesn't happen. Best practice says you need to feed them well, and this also coincides with trying to get optimum mammary gland development. I mean, we weren't trying to mess up mammary gland development. That wasn't the aim of the study. We wanted to feed them. So all the animals got fed very well in the last 50 days, and I'll show you this on the graph and you can see what happened. And then about 4 days after kidding, we applied the second set of nutrition treatments. So that was done because it takes a few days for the lactation to set in, and we didn't want to impact that. We wanted lactation to start and then influence the lactation by altering their feed supply. And then the experiment, the intensive part of this experiment finished at weaning time, when we weaned the kids and all the animals were removed from the feedlot into grazing paddocks. We followed all of the animals for the following 18 months. So they've shorn 3 times. So this graph here shows you the relative amount of feed that the animals were given. So this group treatment here called M is a maintenance treatment. We tried to maintain the live weight of the does during mid-pregnancy. I think we did pretty well. This is the actual amount of food that they were given. And the control treatment, which I mentioned before, was the one where we wanted them to lose several kilos during mid-pregnancy. So this is the feed. So you can see here, for example, for about 4 weeks, they were given about half of maintenance diet. So we put a fair nutrition stress on them, but that, as you'll see from the live weight graph in a minute, that resulted in them following a normal pattern of live weight change. And we also had this supplemented group here, which we fed very well. We wanted them to grow. They were growing about 100 grams a day. So they are the 3 mid-pregnancy treatments. And then you can see from about day 100, we started to increase the feed for the controls and the maintenance group, and they ate progressively more and more. And during the last 30 odd days, the intake of all of the treatments was the same. They were all eating the same amount. So that's what we wanted. We didn't want them to abort. We wanted their mammary glands to develop. And then following kidding, as I was saying, the groups were split, and this is the ad lib group. So this group here at the top, they were fed as much as they could eat. They were fed to appetite, and you can see here that they're eating about 4 times what the maintenance level would be. And the other group restricted to 70%. That was an arbitrary figure we chose. We thought that was going to be severe enough. We weren't trying to stunt the kids as such, but we chose 70%. Now, one of the things that happened here is we didn't realise that the ad lib animals were going to eat 4 times as much. I mean, usually getting animals to eat 2.5 times maintenance is a pretty good achievement. But getting these goats at 4 times, as it turns out, I don't think anyone else has reported that happening with goats anywhere. Now, doe live weight during pregnancy is shown here. So this is entering the feedlot. They weighed the mean weight was about 34.5 kilos. The maintenance animals maintained that weight. Remember, we've got to allow a little bit for fleece growth and also placental development. You've just got to allow a little bit. You can't get too serious in terms of weight loss. And then these animals here lost several kilos. So by day 90, the control animals weighed 33 kilos, and the supplemented ones were nearly 38 kilos. So we had quite a divergence, and you can see that the curve stayed roughly parallel. There was a slight catch-up here for the controls, but they never caught up to the other groups. So that's the labels: fed to lose weight, fed to maintain, and fed to grow. I thought I'd show you the reproductive results here. It's always a bit tricky with relatively small experiments. For reproduction experiments, need hundreds and hundreds of animals to get really precise results. But these results, I mean, we're pretty careful here. We had 34 goats in each of the different treatments, and about 12 of them in each group had twins. So we're expecting 42 kids in each group. And after kidding, we had on an average basis 1 kid per doe in the control, and for the maintenance and the supplemented, it was about 0.9 of kids. So we had kid mortality, as you might expect. As soon as you want to go kidding, it rains on you. That's not very helpful. But I think the most important result, this is not so dramatic. It's pretty typical of what might occur in normal field situations. But what was most interesting was with the control animals. The reason the kidding was 1 per doe and not higher was because we had about 18% of the expected kids were not born. The fetuses had been reabsorbed, or they'd aborted and we hadn't noticed. And that was a very significant result. The other thing that was most interesting was kid live weight. So we thought we may have influenced kid live weight. These results aren't statistically different, but if you had a large number of animals and got a similar difference, then you would pick something up like this. I mean, a large number of animals, these differences are likely to impact on general survival. Looking at the doe live weights after kidding. So at kidding time, the average weight was about 40 kilos. And you can see here with the goats fed ad lib, they put on a lot of weight fairly quickly. This is during lactation. Lactation sets in. They put on about 4 kilos and maintain that. They're actually putting on a lot of body condition. I've got body condition score measurements, but I'm not presenting them here. But the does put on a lot of body condition and weight, and also had a very big lactation. And the ones we restricted, you can see the restriction to 70% was enough to result in the animals losing weight. And so the weight dropped from about 40 kilos back to about 37. So it was about 7 kilos of difference by week 10. So these does were losing body condition. They were basically lactating off their backs. Kid live weight. This is a graph showing the different treatments, mid-pregnancy treatments. So the top line here is the supplemented group, and the bottom line is the control group, and the purple line showing here's a weaning weight. So we did get differences at weaning, perhaps not as much as I expected, but they're still different. And those differences at weaning basically stayed the same for about 8 months or so. So after about 10 months, the kids' weight started to get closer, and following that out to 18 months or so, they compensated. They ended up, the lines got closer and closer together. Now this is the live weights for the treatments, the postnatal treatments. So the black triangles are the ad lib fed ones. So these are the does that grew, and you can see their kids ended up being about 3 or 4 kilos heavier than the ones that were restricted. And those, again, those differences stayed like that for about 8 months, and then the lines started to join together. So we're doing all this because we want to see if we can influence the skin follicles, and skin follicle measurements are tedious things to do and hard to measure, which is why most people have avoided doing it. And most of the studies have only been done on small numbers of animals. So with goats, the previous studies have only looked at very small numbers. We had over 100 kids, and we took skin samples 4 times. We took samples basically at birth as soon as we could get to the kids. We took them a sample just at weaning, and we took another sample at their first shearing at 6 months of age. So we're trying to see whether there was any change. And the last one we took at about 15 months of age, just before midsummer. So the length of day could influence follicle development. So we thought, well, that's the best time. We also took follicle samples from the does as well. So we knew what the does were like, and that's an important parameter that can be used in stats when you're doing the statistical analyses. It helps you detect smaller differences. So the main findings here are shown. So this graph is showing you the age of the kid and the ratio of secondary follicles to primary follicles. So normally what happens is the follicles develop in groups, and you can count the number of secondary follicles within those groups, a bit like a little family. And the aim is to get more secondary follicles. So you can see here at birth, about 2.5. The SP ratio is about 2.5, and that's what was reported in literature from South Africa and Texas. So what we got here was what we would have expected, that we didn't influence secondary follicles at that point. There's no statistical difference, and the numbers are the same as previous people's reported. But by 114 days, by weaning time, we actually had significant differences between the treatments. So you can see that the best treatments had SP ratios of about 10.5, and the worst ones were about 8. So the difference there is about 25%. And those differences stayed the same right to the end of the follicle study. So once we know that follicles are supposed to develop in this period, and we influenced the numbers by some of our treatments, and those differences remained. So in terms of summarising the statistical analyses, we had significant interactions though between the mid-pregnancy nutrition treatments and the postnatal pregnancy treatments, and it affected every measurement we did of the SP ratio and also the total number of follicles that were present. The ad lib feeding during lactation increased secondary follicle numbers. There was a very strong effect of that. So feeding really well after kidding increased the number. And we also detected an effect of feeding on the number of medullated follicles, so Kempe fibres. So the worst treatment, which was the control and restricted, in other words, the two low growth patterns, the animals had fleeces with more medullated fibres than the treatment that had the best nutrition. So I just want to show you some photos. This is a microscope slide of the skin follicles. So you take samples of skin, and you have to very carefully slice the skin in such a way that you can get to the right depth where the follicles are present. And so you can see here, I'm just circling here a follicle group. So you have a primary follicle with two laterals. So they usually get 3 primary follicles in a group. And then the secondary follicles, which I'm now pointing out, the smaller circles, they develop around these primary follicles. So here's a group. So you can see there's different groups. I'm just circling different groups. And so when you do this sort of a study, you have to measure up a whole lot of these groups. You don't just measure one of those, you measure as many as you can and try and get the best estimate for what was present at that time. So this is saying at birth, the secondary primary ratio was 1.8 on average, and 15.5% of those fibres were medullated, which is a hairy birth coat. So here's some other examples. So here's an animal, the same animal that had 1.8 and 15%. At 15 months of age, the animal's developed. The SP ratio is 7.9, and it's still 12.7% medullated. And here's another animal. This one is on the very good treatment, supplemented and ad lib feeding, SP ratio 3.4 and 9% medullated. And then here's a close-up of that same animal. SP ratio is 12 and medulation was 2.8. So that overlays it. You can see a number of the follicle groups there. So this is fairly tedious work doing this counting. Another way to try and understand how many follicles there are is to estimate the secondary follicle number index. And I'm calling it index here because it's not an actual, it's not a real accurate number count, because what we did was to measure the surface area of each kid and then multiply it by the follicle density. So you get an estimate of the total number of follicles. And you can see here, this is the follicle index here, and the age of the kid, and Again, at birth, they're all similar because they're all similar sizes, and the density is similar, but these lines diverge so that by 180 days of age, there's quite large differences. But really, the differences that exist at weaning are still there at 15 months of age. Just another way of trying to estimate what's happening with the follicles. Now, the thing I suppose here is the real economic issue is what does it do to the fleece? So I'm just going to put up some numbers here for the fleece production. So this is the total average values for the three fleeces that we had, 6, 12 and 18 months of age. And you can see here, this is a total fleece production of these animals, about 3 to 3.4 kilograms of mohair they produced. This treatment group here, the CR group had the lightest fleeces, but the other ones, the treatments are all similar. In terms of mean fibre diameter, we had most of the fleeces averaged about 29 microns, but the SAL, now the supplemented kids that were then given ad lib, so this is the best treatment. Their fibre diameter averaged 27.3 micrometers, so they were significantly finer than these coarse ones. And the staple length was also impacted, and most of the fleeces averaged about 15 centimeters, but the well-fed animals, the fleeces were shorter by about 1 centimeter. So that was the shortest fleece, but they had the finest mohair. So it looks like there's competition going on here. We've got more follicles in this treatment group, and that means the theory goes that we've got more competition for nutrients in the skin, and it's resulted in finer fibres, but they're a little bit shorter. So there's more of them, they're finer and just a little shorter. So providing they're not outside the same length class, that's not a problem. But if you're selling your fibre and getting the appropriate premium for being a bit finer, then that should be worth more. So that's what we did. Well, that's what I did with the data. I put through discount value on all of the fleeces based on an analysis of the mohair market. These prices were based on, or the discount were based on a big statistical analysis that was done of a whole lot of objectively measured mohair sale lots in Australia, and you can apply a number of different prices to it, but the price we put down meant that we got these values for the fleeces. So the SAL kids produced fleeces during that time that were worth just under $77. The MAL, so that's the maintenance group followed by ad lib feeding, $66. The control AL group, $61, and then you've got the SR group at 63, the MR at 66, and the CR at about 63. So that price analysis demonstrated that the SAL group with the finest mohair produced the most valuable fleeces over that first 3 shearings. The thing that's interesting is that the MAL group, if you look at the numbers, the MAL and the MR group, 66 and 65, they're averaging about $66, and that number is higher than the control treatment groups at 61 and 62. So there seem to be, if you go back to the mid-pregnancy treatments, there seemed to be about a $4 difference between those groups, which is not a lot, but it adds to the $13 difference that we've got at this end. So here's our kids again. So on the left, we've got a doe with her kid that were in the control and the restricted treatments. And that doe weighed 37 kilos when the photo was taken. Her kid was 11 kilos. That kid produced 2.6 kilos of mohair, which was worth about $57. And the kid on the right, its doe was, at that time, weighed 49 kilos. The kid weighed 23. Now, there is a sex difference here, but I'm not worried about that at the moment. And the fleece value for that kid was total 3.8 kilos, and it was valued at about $87. So that's examples of the extremes we had in this study. Fortunately, those animals were well behaved because I was the only one trying to take the photo here, but they were very used to us, of course, because we were handling them, we were feeding them every day, and we were handling them quite frequently, so they were used to people. And you can see there that they're not really too worried about me. But one of the things that was interesting was we did find that the males in this study produced higher value fleeces than the females. So there was a difference in diameter, and there tends to be a small difference in weight of the animals. So that came up, but wasn't the main point of the study. So look, just to sum up, what did we find? Well, what we did was to subject does to nutrition treatments which could be done on a farm. You could have restricted feeding or ad lib good feeding in lactation, and you couldn't have a variation in seasonal conditions during pregnancy. And they're all practical things. It's the control was a normal. You could feed a little bit to get maintenance, or you could feed a lot to get animals to grow. And what we found was that the optimum feeding of the does provided a $13 benefit in fleece value during lactation and a $4 difference during pregnancy. Clearly, feeding costs money, but it does produce more valuable fleeces over the lifetime of the goats, and those benefits remain. So that's something that people need to evaluate themselves. It's going to depend on your circumstance. Some people have crops. There's a range of seasonal conditions, and you can apply this information in different ways. So, for example, if you had a drought and things were pretty tough, then what that's likely to do is to produce kids that will grow coarser mohair, which would be less valuable. So if you had to cull animals, culling those kids would be better than culling kids that were born in good years where they grew well and had strong growth during lactation. The other thing that was important finding that came out was that poorly fed does had more fetal loss. So it's likely over a number of years that if you're in tough nutrition conditions, then the does aren't going to reproduce as well. They'll have less kids, and they will lose weight during lactation as well. That's probably pretty common. And what we demonstrated was better fed does had heavier kids. They had much greater lactation, and the does were able to gain weight. And so at the end of that period, they were quite significantly heavier than poorly fed goats, and that would translate into better kidding performance in the following year. So to sum all that up, there are some nutrition combinations which permanently increase skin follicle populations, leading to finer and more valuable mohair. And ideally, good nutrition in lactation and preferably maintenance or better nutrition during mid-pregnancy would be the target for mohair growers. So I think that's the end of the slideshow. And that's all good.
Thanks, Bruce. With sheep, I was trying to remember from Lifetime Wool days, but I thought they were secondary follicles were developed at pre-birth, but obviously goats. That's a genuine difference, or am I confused?
Now I've just got to get back onto you. Here we are. Well, there's some secondary follicles develop before birth, but not many. So with the goats in that study, let's say they average 10. The better fed goats average 10, and that number is very similar to all the previous published reports in South Africa and Texas.
Yeah.
So that's what the final number is 10, but at birth the secondary to primary ratio number is only about 2.5. So just as a rough ballpark, about a quarter of the secondary follicles are present at birth, and the other 3/4 are developed during the early part of up to weaning, really. Some depends on when you wean, but we weaned at 13.5 weeks, and lactation had dropped off quite a bit by then. So I don't think that was early, but yeah.
So all right. I'm just trying to think back to Lifetime Wool days, but because I think pretty much show our treatments, they continued into lactation, so it would have been confounded, I suppose, whereas like both happening. But did you ever? I might have missed it, but did you have a single twin effect in that, or are they all singles? Or I might have missed that at the start.
We had twins, so by and large there were some effects of twins and singles. Twins are always under pressure, nutrition pressure, because they're competing. So the twins tend to be smaller, and so anything that's related to size tends to impact on the twins. There's different reasons to have twins, so you just have to get your thoughts clear about that. But look, I suppose there's been these general rules of thumb. So certainly when I studied animal production many years ago as a teenager, people would say, well, you need to feed well during lactation. And they used to say 2.5 times maintenance was a sort of a rule of thumb then. But our Angoras in our study here got up to 4 times maintenance. So they have the potential to, certainly when they're lactating, and their lactations were really good. I mean, they were producing, we measured milk production, and it was quite high. So like 1.5 kilos, 1.8 kilos a day, which is not a bad effort. I mean, there's dairy goats that struggle to do that sometimes.
I'm pretty sure I was there for that in my work experience.
Yeah, well, it was good. Very interesting. I mean, there's quite a, I ended up writing quite a few science reports about it, but this is the main reason we did the work, and we did have a big impact, So I think the thing that's interesting, looking at the good treatments and then the dodgy treatments. So dodgy treatments, the things you don't want to do, you don't want to have good nutrition in mid-pregnancy and then have a restricted, terrible drought sort of circumstance in lactation. That gives you a bad outcome. So that's why I talked about there was an interaction between mid-pregnancy and postnatal nutrition. That's because the good mid-pregnancy coupled with the bad lactation gives you a bad outcome. Yeah. So not sure, explain the hormones and everything. Well, I can't do that. All I can say to you is that they ended up in a bad state, and that's something you don't want to do. Now, look, you might get caught. You might have a flood or something, right? You've got no choice. But knowing which ones those kids are, it's likely, on average, they will be worse. They'll produce less money for you than almost any treatment that ends up at ad lib is better.
Yeah. So I guess managing that is about well, I guess kidding time's fairly limited by when they want to breed, but it's making sure you're feed budgeting properly so that you're spending, like, that you've got feed. If it is a tight year, you still need to remember that lactation's a key and will have fairly permanent impacts on the productivity of those goats if you don't look after them.
Yeah, that's right. If you've got that's right. Feed comes in different forms. So clearly, a pasture, if you're in the spring and get a good spring flush, then yeah, you want to let the kids get into that. If it's in some sort of supplementary feeding, whether it's forage or grain, then yeah, it's some in winter would be helpful, but you get a bigger bang for your buck in the spring. So if you're going to be in a circumstance where spring fails, then that's where you're going to get the best bang for your buck. You're going to get more money by feeding well in lactation.
Does it have to be milk? I know in the drought, a lot of merino producers wean lambs at 6 weeks old and put them on sort of ad lib barley, and anecdotally at least, there was a lot of skin development in those animals through being, like, compared to what they would have been under a drought scenario. Yeah, I guess, is that an option if the season does fail on you? Are we better off getting those kids onto high protein, high energy tucker so they can develop closer to their potential, and obviously once your mum starts lactating, her energy requirements drop? So is that something that you've experimented with or not?
No, we never got to that point, Mark. The industry didn't fund that work.
Yeah.
That's, as you said, that's been demonstrated many times. Where I worked at Werribee, my boss did work like that, when at 6 weeks and with lambs and get them up and away. I think it's more challenging with goats. The goats aren't as big as they could be. They don't seem to grow as quickly as sheep, despite what I was saying about the does eating lots and lactating well. The kids were still, in my mind, relatively small. I had hoped that their really good treatment, their kids would be much bigger. So I can't explain why they didn't grow more. But early weaning, it's about the size of the animal and their ability to eat hard feed. And 6 weeks for kids, there's probably people who've tried it because we've talked about it on and off, but I haven't seen any good evidence to say that that's a wise move. You might be better to leave them on their mothers for longer, not feed them to such a large extent.
Yeah.
But,
what about a crepe feed? Is that something like so?
Well, technically these if I showed you those, if you look at the pictures again of that feeding system, we had troughs which the bigger kids could get access to as when they got a bit larger. So we did not measure the actual intake of the kids. I mean, it was a doe and kid unit.
Yeah.
So there was some pellets eaten by kids. I mean, kids would jump up in the trough and like all kids do. So things we're certain about with feed, there was no stealing of feed. The way we ran this experiment, it was just not possible for an animal to steal feed from another animal. We were really certain about that. What is less certain is the actual amount of hard feed that the kids may have eaten when they're a bit older. So from 6 weeks, they'll start eating more and more, and we don't know how much of that they had. So the feed intake values there are, we're saying the does intake, and it would have been predominantly the does, but some of the kids would have eaten something.
Yeah, cool. I guess if we fast forward past, like, there are Australian genetics, is like with shift in, like, I guess particularly the Texan imports were higher fleece weight. I'm assuming they genetically had a high SP ratio, did they? Like they have more follicles, or we haven't done that work?
That's unclear.
Yeah.
That's unclear. You could get just more productive animals. They could be growing longer fleeces and coarser fleeces, so you get more weight. But the published SP ratio figures for the animals in the study I've just talked about and the previous work was similar. Actually, they were so close that it's all you can say is that it's relevant to other genotypes. That's what all I could say. But we didn't test other genotypes at the time. People say, well, why didn't you? Well, at the time, the animals were in quarantine or just coming out of quarantine, so it was too difficult. You don't want to be doing these studies with crossbred animals. It's just a bit confusing. You're not quite sure exactly what you've got. It's hard enough doing it when you've got as much control as possible. But I mean, you could try and repeat this work in different ways. And if I had another shot at it, we'd do things slightly differently, but it would be just as difficult to do, and it's very expensive. I mean, I was fortunate to have access to staff to help, but that's not the case today, so it would be difficult.
Yeah, for sure. Just, I mean, obviously mohair has been the focus tonight. You also spent lots of time thinking about cashmere. Is there parallels with cashmere's having secondary follicle development and getting therefore more cashmere production or more down production?
Yes, there is. The cashmere, I mean, cashmere numbers are pretty similar, really, when you come to SP ratios and things like that. So, yeah, that it is possible. There was one study done in New South Wales, Queensland, looking at follicle development in the cashmere feral type goats that they used. And they only imposed nutrition treatments for 30-day blocks, and I think that's just too short. It's by the time you start, and usually it takes a week or two for a nutrition treatment to kick in. So 30-day blocks, I think, was perhaps a bit tight to try and detect something. You'd have to have lots of animals, and they didn't really have in my recollection of their work, they didn't have a big impact on things.
Yeah.
Yeah, but I would think they'd be very similar. I mean, we've seen the work on sheep shows you can influence SP ratios. Merino sheep have got a much greater number, and much greater density, but the influence wasn't to the same magnitude that I detected. So, we were getting 1.5 micrometer difference in fibre diameter, whereas I think the wool work, it's more like 0.1, 0.2, 0.3. So there's an influence, but it's not. And why that's important for mohair is that in those mid to high 20 fibre diameter range, that's where there's a big price discount. So you increase fibre diameter by 1.5, 2 microns, that can lead to 10, 20% reduction in fleece value.
Yeah.
So it's quite severe. And so that's how those numbers came up the way they did, because that discount curve is quite strong.
Yeah, and particularly in their productive life, like running weathers or whatever, you might only run them for a couple of years before you move them on or whatever, and all that period is when the highest value is on.
Yes, that's right. Unfortunately, we couldn't. That's the other thing. Unfortunately, it would have been great to have kept these goats for another couple of years, but the research institute was being closed, so we couldn't do that. That was disappointing from my point of view. But I think we demonstrated the point. Getting out to 3 fleeces demonstrated that those differences were there. And at that age, you've overcome any impact of being a single or a twin, or low or high nutrition, or some of those other small things that have impacts. They're sort of birth impacts, or up to weaning impacts, and differences there at 18 months, their lifetime impacts, which I think is what they found at the sheep work that was done at Hamilton. It's a lifetime wool.
Yeah, that was first job out of uni. Yeah, it was. I mean, definitely had hung around. I think we only got to. I don't think we measured them after 2 or 3 year old anyway. But the original stuff by Kelly and stuff in the West showed that it did hang around. So I mean, once you set up a follicle difference, then it's going to be there until they start shutting down again, I suppose.
Yes, well, the shutting down one's also interesting. Questions we could talk about that, whether they should or shouldn't shut down. But I think with mohair, if you've got your eye on the most valuable fleeces, then like you just said, that once animals get past 18 months to 2 years, then the animal's getting bigger. So this, what we're now talking about, is so-called micron blowout or fibre diameter increase with age. And the work that we've done demonstrate actually it's not age, it's actually the size of the animal that's the most important thing. So that's really a discussion, I think, for another webinar. But you get to a certain size and the animals will produce coarser mohair, and you've got to make a decision. We're selling them for meat, like, because you want to make space for the next productive lot of animals. So getting that system in place is the key to making money here. You keeping the does for the breeding flock, and you're selling off everything that you don't like, those that are born in a drought, those that are too coarse, and those that are getting too heavy.
Yeah. Yeah, I mean, it's like, I always think of it like a forest of trees. Like, you thin out a forest of trees, they grow bigger. But if you put lots of them there, they'll be skinny little trees. And so it's my simplistic.
Yeah. Well, I mean, the other thing is genetics. Of course, there's all different things that you throw in the mix, but they're medium term issues.
Yeah. Well, that's the. Yeah, all right. We won't let you get on with your day, Bruce. But it's great to have your expertise along, and we definitely can wander through those other 5 topics once you get back from the US and start knocking off a few more of. I think understanding the stuff you did with the project test animals, with the sort of nutrition, the direct impacts of nutrition throughout the year, like of the animal itself, not of the fetus, is also obviously going to be of high interest.
Yes, there's lots of things impacting on productivity, and people are aware of things like intestinal parasites and so on. They're pretty bad. You can have bad impacts. Shearing, even teeth wearing out with older animals. That's at the other end of life. So you can pick that up. Yeah, that's good. Oh, well, thanks for having me, Mark. It's nice to talk about that work. It was very intense, a lot of work done to try and pick up things that have lifetime impacts. So I hope people who are listening find that useful. And there's plenty more information if they want to know more. Then there's a lot more information about those animals.
Yeah, I think that's what we'll encourage people to do when they listen to this recording, is to get those questions on the hub so we can pass them on to you and see, just so we can get any information out that people need to know or want to know.
Yeah, that's right. No worries. Good on you. Okay.
Thanks, Mark. I'll hand back to Georgia.
Thanks,
wrap that up.
Thank you.
I know what are they, 5 or 6 papers, Mark?
Yeah, it's heaps of stuff. So yeah.
And then we had to slaughter some of them as well in the end. So
Beautiful. Thanks very much, everybody.
Good on you. We'll see you later.